Okay, so I'm going to tell you about a field campaign. It was a local air quality field campaign that we just wrapped up. Gabi and I had the responsibility for this. We did this with a lot of partners and with funding from the state of Colorado and NSF. Many people here in the mountains think that air quality is a solved problem because cities don't look like this anymore, like LA in the 50s. But it's not really the case. If you come down from the mountains often in the afternoon, you see very visible pollution in the boundary layer over the plains here. And even in cases where you can't see any visible pollution, this is one of the flight days, and this is downtown Denver from the aircraft, we actually exceeded the ozone standard that day, so it doesn't have to be murky in order to be unhealthy to be outside. The National Air Quality Standard, it took us about 20 years to come back to a standard that was originally established in 1971. We are now at 75 ppb, and people are trying to get it down to 65 because 75 is still a fairly unhealthy value for quite a lot of people. While we've made some progress, especially in the eastern United States in the last years because of power plants being cleaned up, we would be back right here if we went back to 65 ppb. The western states really haven't improved all that much in the last 20 years or so. So what else can we do? We've done already the easy things already. We've put cats in cars. We have improved combustion efficiency. Industry emission reductions have been in place, although they could still a little bit stronger. We also have cleaned up our power plants. Now it's getting a little bit more complicated. We need comprehensive measurements. Air quality is often informed by sparse ground-based observations of EPA networks or state networks or such. But we have horizontal and vertical mixing, we have recirculation effects, and when we fly around, we often find some unexpected sources. Here in the Front Range, we have quite an interesting mix of sources. We have the classic ones, industry and traffic, but we also have a lot of cows here. We have feedlots, we have very strong oil and gas extraction activities, we have natural emissions, sometimes we have wildfires, we also have long-range transport. And the goal of the project was to figure out when all this stuff mixes up, what does that do to the Front Range air quality? So we designed a number of flight tracks to look at essentially what comes in, what goes out, and what happens locally here with our emissions. And these local emissions are being redistributed by a pretty unique meteorology in the region that is driven by the fact that we have mountains to our west. When you look at it in the north-south, we have usually westerly flow aloft, but upslope effects due to heating of the mountains can bring the air up into the mountains, and it can be caught up in the flow, but it can also, if it's strong enough, be pumped into the mountains themselves. These are all the actual flight tracks, and I'm going to show a lot of this. This is flight tracks colored by a certain measurement. This is our traffic tracer, NOx. When it's red, it's high. When it's blue, it's low, and everything in between. And you can see here, this is mainly where people drive and some power plants. If you look at the oil and gas emissions in the same area, you can see that they are mostly driven by where all our activities are. There's some here on the western slope, some also in our area, and quite a few here right in the Front Range. One of the things that we wanted to look at is the traditionally thought of pretty strong oil and gas emissions from the west. Do they really affect us? And the answer is no. We have so much oil and gas activities now in our area here that they completely overwhelm anything that would be transported in from the western side of the state. If we look at ozone production, this is ozone here on the left side, and this is NOx, our traffic tracer, on the other side. You can see there's ozone throughout the foothills here being formed from traffic tracers here in our area here, but also from the oil and gas tracers in the north. They form ozone almost as effectively, and so as a result, the entire Front Range is impacted by ozone. If you now look at this in a sort of a vertical sense, you can see this is at a 40-degree cross-section of our vertical topography here. You can see that the ozone is being made down at the surface in our areas where most of the traffic is. And as I mentioned earlier, you can see the upslope developing here and bringing the emissions up, being caught up in the clean emissions, in the clean background air that flows along here and being transported here. But we also clearly can see that ozone is indeed spilling over the mountains, and it's affecting mountain communities that are traditionally thought of as being upwind of us, actually. So in wrapping this up, we are dominated by our own emissions. We form ozone effectively. We have two regions. One is traffic, the other one is oil and gas, and they are mixing in various ways. The contribution of the western slope sources is relatively small. We, in the absence of wildfires, really air quality is controlled by ourselves, and we have a somewhat elevated regional background of about 50 ppb, and I don't really have the time to talk about that, but we can.